So we're looking today at the last little part of differentiation. We've got two exam questions for us to have a little go at. Let's just have a little look at both of these then. I'll zoom in a little bit just so we can see it a little bit clearer. So figure 2 shows a right circular cylindrical metal rod, well I can't say cylinder, which is expanding as it's heating. After t seconds, the radius of the rod is x and the length of the rod is 5x. The cross-sectional area of the rod is increasing at a constant rate of 0.03 centimeters squared per meter second. Now this is really important here. Okay, this part here is the bit that's kind of new. That's the bit we need to focus on. Find dx by dt when the radius is 2 centimeters, giving your answers to 3 significant figures. So let's think about all the things that we know here. Okay, so the first thing, the bit that I've highlighted here, says that the cross-sectional area of the rod is increasing at a rate of 0.032. Now what that's telling us here is dA by dt, so the cross-sectional, it's only the cross-sectional area of that. Okay, so dA by dt is equal to 0.032. Now this is the area of the cross-section, just be careful, it's not the surface area. Okay, I'd probably work out what the volume is as well. So my volume of this is going to be pi r squared, just the front, times by the depth, which is 5x. So pi x squared times by the depth, which in this case is equal to 5x. So my volume is this, is equal to 5 pi x cubed. Okay. Find dx by dt. Okay. 4 marks. So I'm just taking a little second to take in what I'm trying to find. Now we've got here, the thing that they've told us is the area of the cross-section. Okay, they've told us the area of the cross-section, they've told us the rate of increase of the area of the cross-section. Now I know that the area of the cross-section, it's probably worth writing that down here. So the area of the cross-section is equal to pi r squared, isn't it? Pi r squared, which is going to be pi x squared in this case. Okay, so I don't actually need the volume just yet. I'm going to leave that over there. Okay, but what I do need is to use the part they've given us, which is that the dA by dt is equal to 0.32. So this is what I need to think about, this part here. How can I use this? Because I know that I've got A in terms of x. My cross-sectional area in terms of x is this. So how can I use what they've given me here to find out dx by dt? So this is, we're going to have to use some kind of chain rule here. And the chain rule for this is going to be that dA by dt is equal to dA by dx, which I can work out, times by dx by dt. So notice how I've split that dA by dt up into x, because that's what they're asking for. They're asking for dx by dt. Now the only thing that I've got this, haven't I? I've got dA by dt. I know that's equal to 0.32. The only thing that I haven't got is dA by dx. So I'm just going to make this a little bit clearer and say that actually this is the area of the cross-section, yes, but actually I'm going to call this A, because that's what I called the dA by dt, didn't I? So this is actually called A, which is the area of the cross-section, we know that. So if I differentiate this, dA by dx, so differentiate, how does the area change in relation to the radius, or x, is equal to 2 pi x times the 2 by the pi, take 1 from the power. Okay? And then I can sub in both of these things, can't I? So I can sub in dA by dx, which I've got. I can sub in dA by dt, which I've got. And I can use this to find out dx by dt, which is what they're asking for. So let's sub in both of these here. So dA by dt is what they've given us, which is this 0.032. Is equal to dA by dx, which is equal to 2 pi x times by dx by dt. So to find out dx by dt, now they're asking for it when the radius is 2 as well, so I am going to have to sub that in. I'm just going to give myself a little bit more space here. In fact, what I'll do is I'll move this over for a second, because I don't actually need this just yet. So, and then let's take that up there. So, dx by dt, which is what I'm trying to find, is equal to 0.032 all divided by 2 pi x. Okay, now don't forget they're asking for it when x is equal to 2. So when the radius of the rod is equal to 2. So when x is equal to 2, let's sub that in. Dx by dt is equal to 0.032 divided by 2 pi times by 2, which is equal to, let's work out what that is, fraction button first, 0.032 divided by 2 shift pi times by 2, which is equal to, annoying, I'm going to write it down and then I'll change in a second. So, dx by dt to 3 significant figures is equal to 2.55 times 10 to the minus 3. Do 3 jumps on that. So 1, 2, 3. It's going to be 0.00255. Let's check that. 1, 2, 3. Yeah, 0.0255. Okay. So that's that first part done. Part A there. I'm just going to check that before I move on. I'm positive I got it right. 0.2. 0.0, yeah, fine. Super. Okay, so this second part here says find the rate of increase in the volume. The rate of increase in the volume. So the rate is dV by dt when x is equal to 2. Okay, so I've worked out right at the start of this. I did work out what the volume was in terms of x, but they're not asking for that. They find the rate of increase in the volume. So the rate of increase in the volume is going to be equal to dV by dt. That's what we're looking for. Okay, now I can't work out dv by dt because my v is in terms of x. So if I've got something in terms of x, I'm going to work out in terms of that. So dv by dx times by dx by dt. Now take note, I've already got that. It was from the first question, haven't I? So dx by dt is this part down here, which I've worked out in the last question. Now this, we can only use this here because it says when x is equal to 2. And it was x equals to 2 in the last one, wasn't it? Okay, so let's substitute these in now. Now, actually, before I do that, I do need to work out what dv by dx is. So dv by dx is equal to, bring down the 3, take away 1 from the power, it's going to be 15 pi x squared, like so. 15 pi x squared. So this is equal to dv by dx, which is equal to 15 pi x squared, times by dx by dt, which is, when it's 2, is equal to that, which we said here. So times by 0.00255. However, we know that we want it when x is equal to 2. So actually, I do need to sub x is equal to 2 into this. So dv by dt, so the rate of increase of the volume is equal to 15 pi times by 2 squared times by 0.00255, like so. Let's work out what that is. So 15 shift pi times by 2 squared times by 0.00255, which is equal to, why not? .48. Do I want it to 3 significant figures again? Probably. So 0.481 in this case. 0.481. What would my units be on that? Centimeters cubed per centimeters cubed times by 10 to the minus 1. Don't need to put your units on that. Just check that. Annoying, they've only done to 2 significant figures, but we are right. Ooh, I've put per time. Sorry, it should be s to the minus 1. Seconds, obviously. Not time. Time isn't a unit. Well, there we go. I'll give you a second to get that down. Okay, so we've got one more question to have a little go at. Again, it's a past paper question. So get this down. Get this down. Now these are common questions, okay? These are really, really common questions. Alright, I'm going to start having a little go at it. So, figure 1 shows a metal cube which is expanding uniformly as it's heated. So we're heating up and this cube is growing, okay? At time t seconds, the length of each side is x and the volume of the cube is v. Show that dv by dx is equal to 3x squared. Now the first thing I'm going to do up here, okay? Let me get rid of, in fact I'll do on the side. I'll zoom out a little bit. I'll do it on the side. So the first thing I'd probably do here is I'd probably write down what the volume was in terms of x. Well, because it's a nice little cube, we know that the volume is equal to x cubed. In fact, have a little go at this yourself actually before. This is a test of understanding, I should have done this. Have a little go at this one yourself, okay? I'll give you a few minutes to have a go at it. Just get yourself started. Have a little go at this one yourself. Okay, I'm going to go through this question. Okay, I'm going to start going through it. Okay, so figure 1 shows a metal cube which is expanding uniformly when heated. At time t seconds, the length of each edge, the edge of the cube is x centimeters, and the volume of the cube is v. So the first thing I did was I wrote v in terms of x, which is this part here, isn't it? So v is equal to x cubed. Show that dv by dx is equal to 3x cubed. Well, that makes sense because if I differentiate this, dv by dx, this is equal to 3x cubed. Nice, very good. Okay, so the next part says, so this here was part A. That there was part A. Part B, now there's a part which it says here, which is important. The volume is V. Given that the volume increases at a constant rate. Now, it's this constant rate part that I'm thinking about here. Now, you can also, the units will help me. The volume is increasing at a constant rate of 0.048 centimetres cubed per centimetre squared. Now, what that's telling me here is that dV, so that was part A, let's do part B here. dV by dt, so the rate at which it's increasing, is equal to 0.048 centimetres cubed per second, which makes sense, dV by dt. Okay, that's what it's telling us there. Find dx by dt. Okay, so if I want dx by dt, now there's a million different ways you can write this out. I'm just going to write this. dx by dt is what I want. Now I haven't got dx by dt, and I haven't got anything which links x and t, but what I do have dv by dx, so I'm going to split this up into dx by dt is equal to dx by dv times by dv by dt. Okay? Notice that if I cross these out, it'll just cancel to give me back to dx by dt. Now, they've already told me what dv by dt is. That's this part up here, isn't it? And if I want dx by dt, it's going to be the reciprocal of if I want dx by dv, it's going to be the reciprocal of dv by dx. So dx by dv is equal to 1 over 3x squared. So let's sub these in then. So dx by dt, which is what I'm trying to find, is equal to 1 over 3x squared times by dv by dt, which is equal to 0.048 there, like so. Then my last little part is to sub in when it's asking for it when x is equal to 8. So dx by dt is equal to 1 over 3 times by 8 squared times by 0.048. So let's work out what that is. So fraction button, 1 over 3 times by 8 all squared times by 0.048 there, like so, is equal to 1 over 4,000. Oh, it's nice that, isn't it? Let's keep it like that. So it doesn't ask it for, no, it doesn't ask it to round it. So 1 over 4,000. There we go. Units on that are going to be centimetres per second. Okay. Last little part now. Find the rate of increase of the total surface area of the cube when x is 8. So this last part now is not asking for the volume, it's asking for the surface area. Let's give myself some more space down here. So the first thing I need to do for part C is let's write down what the formula what the surface area of this cube is in terms of x. So my surface area, I'll call that A. My surface area which is equal to A, Well, if one face is going to be x squared, but there's 6 faces, my area is equal to 6x squared. Okay, that's what my surface area is there. And it says find the rate of the total surface area of the cube. Now what they're actually asking for is this. They're trying to find dA by dt. How is the surface area increasing over time? Now, I haven't got a formula for area in terms of t, but what I can do is I can say that this is equal to dA by dx, which I can work out if I differentiate this, okay, times by dx by dt, which I worked out in part B, okay. Notice that if I cancel these, the dx and the dt, I go back to the thing which I want, which is dA by dt. That's what they're asking for, the rate of increase of the total surface area. So, the first thing I'm going to do with this one is I'm going to have to work out what dA by dx is. So dA by dx is equal to 12x. Okay. I already know what dx by dt is when x is 8. Very similar to the last one. They've used x equal to 8, so it follows through quite nicely. So I can say now that this is equal to dA by dx, which is 12x, times by dx by dt, which is that 1 over 4,000. Take note that I want it when x is equal to 8. So, the last little part, let's sub all this in. dA by dt is equal to 12 times by 8, all times by 1 over 4,000. Let's work out what that is. Last little part. So 12 times by 8 times by 1 over 4,000 is equal to, hey, close that bracket, 3 over 125, and keep it like that, is equal to 3 over 125. Units on that, if it's the surface area, is going to be centimetres squared per second. Alright, I'm just going to check that answer and then give you a second to copy it down. Yeah, I think we've got it right. They've not done it as a fraction, but 3 over 125 is that. Just check that actually. Just going to check that that's 3 divided by 125, 0.024. 0.024, yeah, perfect. Brilliant. So there's that. Get that down. That's the last question we're going to have a look at.